But radiation is basically light. It can be particles, it can be waves, but we're not going to use those words too much today. We're mainly going to just call it light. We have visible light with this rainbow. So visible light is all of the light that we see. That's the same type of light that comes out of our light switches, that we turn on our car headlights, all of that type of light. The main type of light we get from the sun is visible light. That's the only type of light that our eyes can see. So everything we see is bouncing around visible light. And then you've probably heard about ultraviolet light. We're going to talk a lot more about ultraviolet light today, but that's the special kind of light that's in these flashlights. So please be careful not to flash this light into anyone's eyes.
Your skin cells burn and it starts turning red and hurts a lot.
So another question, what causes sunburn?
It makes like too much energy like go through your body.
We get sunburns because of UV radiation from the sun, from ultraviolet radiation, just like the ultraviolet light in here. But that's why you have to reapply sunscreen frequently and pretty often in order for it to work. Because if it doesn't, then it's going to absorb into your skin and eventually come off, and then this UVB light can hit your skin again. So now we're going to get ready for our experiment. And like I said, we're going to need this flashlight, we're going to need some some beads, and we're going to need our sunscreen. How can we see if sunscreen works? Sunscreen, we saw lighter colors, and that tells us that the sunscreen absorbed some of that ultraviolet light. If the sunscreen didn't absorb any light, then they would be the same color, the same brightness. And so that's really cool. We just proved that sunscreen works with these beads.
Hi, I'm Dr. Zhelei Shen. Today I will talk about radiation. First, I want to share my journey from China to the United States. To West Coast. So this is where I'm working right now. Radiology is a branch of medicine that uses X-rays and other high-energy radiation to diagnose and treat disease. And then the second branch is called radiation oncology. That's actually the department I'm working in. It's a branch of medicine uses carefully targeted doses of high-energy radiation to kill cancer cells. The third branch is called nuclear medicine. It's a branch of medicine that uses radioactive material to diagnose or treat disease. Yeah, the bright regions, those are the bony structures.
I can see the head and mostly the neck is the part of it, the picture.
I can mostly see the lungs, but I can kind of see the chest bones. I see the feet bones.
I could see also the feet bones, and there are many parts of them to make them move, and also I think with the under one, under the feet bones.
Yeah, CT you can see more details about the soft tissues. All these images are like a cross-sectional. But back here, sometimes we have the sagittal, we have the coronal. Most of them are from like the side view or something like that. But the CT usually we show a series of axial view, or we call transverse view. So let's start with this one here. Any guess?
The top of our head, the brain.
All right, awesome. Next one. Yeah, awesome job. This one's a little tough, but give you a clue. You have a bony structure here. You have some bony structure here on the side.
And now, Dr. Shen, we have some questions that the students asked yesterday, beginning with Alejandro. He asked, how many types of light are there?
How many types of light? Like a visible light, that kind of question?
I think he means like all types of radiation, right? Which is a hard question. Yeah.
Oh, yeah. So if you remember from the spectrum, so we have the visible light, we have the infrared, we have the microwave, radio wave, and then on the other side, we have UV light, we have X-ray, gamma ray. So at least from the spectrum, I count 7. Yeah, but there could be more. Yeah. There's a neutron which is not on that spectrum. Yeah, at least 7.
Awesome. And then from Juan, we have, how do your radiation machines work? And I think he means like, how do they produce the radiation that we use to take images or to treat cancer?
Excellent question. I could give more detail. But for example, X-ray, it's like an X-ray tube. Usually it's in a vacuum. And then there's like we call electron, like there's an electron gun, so it shoots the electron, and then there's a target, and then once it hits the target, usually it's tungsten, that will create the X-ray. I mean, the same idea works for LINAC, the linear accelerator, but it's a much larger scale. Yeah, so X-ray usually is like a lower energy, like a 100 kV, but then for the LINAC machine we use to treat cancer, that's like a NV, which is like 1,000 times higher energy.
Awesome. All right, let's thank Dr. Shen again, because that was so great. I hope you all had fun. I learned so much. I hope you did too. And that's it for today for WonderKids.